All right, this is a BDA chart. Okay, it's used for modeling. Now, the concept of modeling traditionally has been, building something three-dimensional, something tangible. But a model is just a way to represent as many things going on in a phenomena as possible. So, for example, you guys just saw I pulled a card between two jars of water, one um, red water, one blue water, and the red water was hot and the blue water was cold. Now, hopefully we hypothesized something, and then based on that, we pulled the card out, and did something happen that you were not expecting, or something happen that you were expecting? Well, in either case, that poses the question, well, why didn't the liquids fully mix, right? Because we've been learning through previous classes that if I have the diffusion of uh, uh, higher concentration, lower concentration, right? I'm going to lose, the red's going to flood down and the blue's going to go up um, to, to eventually reach an equilibrium, or in this case, a purple equilibrium. But in fact, we only saw in that demo that only the middle was purple and there wasn't really much of it, right? So in comparison to everything else, right? It's a comparison to the red and the blue. So this chart is to model what you think went on, meaning why do you think, um, what do you think happened, right? So it's drawing. Now it's pretty self-explanatory. We have before, during, and after. Meaning, before I would want you to draw, the system, which obviously I'm not going to be uh, grading you on your artistic abilities, especially by my lack of ability, right? Um, so I'm going to go ahead and, try to duplicate this as best I can, right? It's not going to be perfect, as you can tell, okay? Especially as I get a little farther down my smartboard, because it's just odd, right? But here are my three samples, okay? Now, or my three stages, right? Before I pulled the card, so I have my card right here. So before I pulled the card, while I was pulling my card, and then after I was pulling my card. So this is in chronological order: one, two, three. Okay. So the explanation we'll get to in a minute. So you'll draw your model, which these three things right here are the beginning of a model, and then you'll have an explanation after you've drawn your own model. Okay. So before we started with what we had: red on top, we had blue on bottom. That's not blue, right? Let's get rid of that. Fix my line. There we go. And we had blue on bottom. And then when I pulled the card out, we still ended up having, you know, blue on bottom, red on top, but there was a movement of molecules. Okay, there was movement of color. So I had some of my blue going up into here, some of my red going down into here, right? And I kind of ended up with, I know I don't have a purple pen, but kind of a, um, kind of a purple color right at the mouths of the two jars, right? And we can clearly see the movement of the molecules, right? And then after the phenomenon has taken place, when we're all said and done, we ended up with, having our purple little section right here, which, was both blue and red, right? And then we had our red and then our blue, okay? Now, that's just rudimentary model building, right? I have before what happened, what it looked like before, what it looked like after, um, and what does it look like before, what does it look like during, and what does it look like after now, okay? So, usually arrows are a really good tool to use in model building because it's indicating not only direction but also intensity, right? So one thing that you can do, and I'll go ahead and put it down here in the explanation, even though it doesn't really apply for this right here, but when you're doing model building, if I have, say, the amount of light, right? Well, if I have a longer arrow of light, it's not really an arrow, it's horrible. right? A longer arrow of light versus a shorter arrow of light, maybe that means a greater intensity of light, right? Or if I had a big arrow for pressure and then a little arrow for pressure, meaning that the first arrow has a greater pressure than the lower or than the second arrow, okay? But like I said, those are just examples on how you would use arrows in this case, right? Or for a model. In our particular example, we're using the arrows here, right, to indicate the movement of water going up and the movement of water going down. Okay, so cold water going up, hot water going down. But as you notice, we didn't have a full mixture like probably some of us were expecting, right? That's when our explanation comes in, right? Now, this can be in bulleted form, right? This can be in paragraph form, but I would prefer it to be in concept map form, right? Or another word is flowchart, right? Or another type of concept map is called a flowchart. Usually the flowcharts are showing like orders, right? First, second, third, fourth, fifth, this happened, then this happened, so it's showing sequence. Versus a concept map, there's multiple things going on which can lead to an explanation. Okay, I would prefer one of these two. Okay, bullet pull, if all you can use is bullets to explain, do it. If all you can use is paragraphs to explain, do it. But I'm just telling you that using concept maps or using flowcharts, they tend to be a lot more elaborate, and they're a lot more multidimensional, where you can use, this is involved and this is involved, and there's one picture that is, you can draw a bigger picture with an explanation. When, by the way, your explanation can be a picture, right? And because a concept map and a flowchart are more pictures than they are just sentences. And most times, I don't want you to put sentences in concept maps because then they look, kind of bogged down with a lot of words when I want you to try to explain a concept. Okay, so this is a BDA chart, right? You're going to have before, during, after. It's usually you're going to get something like this after you've witnessed a phenomena, okay, like the red water and blue water mixture. Okay, in class you'll have a different phenomena, but you'll still have this chart, and I'll have these charts available for you. Okay, with the BDA chart, this is a small one. You'll also make bigger ones. Okay, so in your bigger ones, with your smaller one, I'm not really. This is plenty, but when you have your bigger BDA charts, right? I want you to have just kind of a small, and I don't want to call it a full explanation, but just well, we'll go ahead and call it an explanation. An explanation as to what's going on in this particular picture, right? What's going on in this particular picture? You guys get my point. What's going on in this particular picture, and then an explanation in the explanation box is the actual full explanation and description of what's going on. Now, in your explanation, by the time it's all said and done, right, there should be one thing that you write on the bottom of your explanation box, and that is a statement that will sum up what went on, and you should be able to defend that statement with evidence. Okay, and the evidence is this model, right, and just based on observation. Okay, so that statement, that clear statement at the end saying, this is happening because of this, and then if somebody says, well, no, this is happening because of this, then you should be able to defend your answer. Now, when I'm talking about defense of an answer, that doesn't mean that, we're gonna go to blows there. It's just when people have conversations in science, it's about, okay, this is why, this is why I think this is because the evidence is suggesting this, right? And if somebody can refute that, then great. What is your evidence to refute it? Okay, and then that brings about healthy scientific conversation. Okay, and then the whole point of this is to eventually lead to, that's good, right here, I'll put it right in the middle, revision. Okay, science is not about, oh, here's the model, this is what it is. It's, here's the model, this is what it is for now. All right, we bring about more arguments, which arguments is not a negative, don't focus on the negative connotation of argument. Argument is having a statement and explaining it and evaluating it from other people. And then based on that evaluation and based on the suggestions, you revise. And then you revise again, right? If we didn't have revision, then we would still be thinking that all matter is made up of, earth, wind, fire, and water. But the idea of matter and the concept of matter has been revised many, many, many times throughout our time. Okay? So the whole point is to have models that show an explanation of a phenomenon. You write out that explanation in your explanation box, okay, preferring a concept map or flowchart with it. Then based on that concept map or flowchart, give a statement saying this is what's causing this, and then be open to critique to allow for revision. And the revision will then only make better models and more accurate models. Okay?